Okay, in this section, we are analyzing functions with successive differences in 9.6. We're going to identify linear, quadratic, and exponential functions from given data, and then write equations that model that data. These are all the different types of functions that we've already done. So you have linear, quadratic, and exponential, and you've already learned that in previous chapters, but now we're kind of putting all of it together. This problem says graph the ordered pairs and then determine whether the ordered pairs represent a linear, quadratic, or exponential function. So I'm going to just plot those points. So 1, 2, 2, 5, 3, 6, 4, 5, and then 5, 2. And then if I connect those dots, that looks like a parabola. So we're going to say it's a quadratic function. That's it. So I want you to take a minute and graph this and then see whether it's linear, quadratic, or exponential. Go ahead and pause the video to see what it is. If you plotted those points correctly, you should see that it is linear, a straight line. So graph the set of ordered pairs, determine whether the ordered pairs represent a linear, quadratic, or exponential function. Again, so I'm going to say -2, 0, -1, -3, 0, -4, 1, -3, and then 2, 0. So what is that? Good job. It's quadratic. Okay, now we're going to see if we can look at a pattern in the table to determine which kind of model best describes the data. So I want you to kind of write this down. This should be in your notes. If you have something that is linear, your first differences are the same. I'll show you what that means in a second. If it's quadratic, the second differences are the same. And if it is exponential, the ratios are the same. So let's look at this table. So all you have to do for the x's is make sure that they're consistent. So -2, -1, 0, 1, and 2. You are just adding 1 each time. So as long as those are consistent, and they should be, you don't even need to worry about it. You're looking really at your y values. Okay, so what are you doing to go from -1 to +1? You're going up 2. What are you doing from 1 to 3? You're going up 2. 3 to 5, adding 2. 5 to 7, you're adding 2. So since you are adding 2 each time, it's linear. And if you graph that, you would see. So if you're adding the same number between each of the y values, it is linear. Okay, let's go ahead and come up with an equation for this one. I know it doesn't say to, but you have to in a little bit, so let's just do it now. Okay, the equation for linear is y equals mx plus b. That's our slope-intercept form. The slope is what you're adding each time, so that's going to be 2 in this case. Your b is your y-intercept. So remember, your y-intercept is wherever x equals 0. So y equals 3 in this case when x equals 0. So y equals 2x plus 3 is our equation. Okay, we're going to look at this one. So look at your x values. They're all consistent. What are you doing to get from 36 to 12 and from 12 to 4? You would say you're dividing by 3, but in exponential, you're multiplying by a number. So instead of dividing by 3, you're really multiplying by 1/3. From 12 to 4, you're multiplying by 1/3. And so on. So 4 times 1/3 would give you 4/3, and 4/3 times 1/3 gives you 4/9. So you can see that in all those cases, you are multiplying by the same number to get from one y to the next. Therefore, that means it's exponential. So an exponential, if you're multiplying by the same number, it's exponential. Okay, so I know that this is a problem that generally you would do by yourself, but we haven't done one of these yet. So let's look at it. Okay, from 9 to 17, what are you doing? You're going up 8. From 17 to 33, what are you doing? You're going up 16. From 33 to 57, you're going up 24. And from 57 to 89, you're going up 32. So clearly that is not linear, okay? So because the first differences are not the same, it is not linear. Now, are you multiplying by the same thing? No, because 9 times nothing gives 17, except 17 over 9, but or 9 over 17. Anyway, it doesn't give you that. So let's just check to see if it's quadratic. So to check to see if it's quadratic, once you check the first differences, you check the second differences. So look at these numbers. What plus what? 8 plus what gives you 16? You're adding 8. 16 plus 8 gives you 24. 24 plus 8 gives you 32. So since your second differences are all the same, you would say that this is quadratic. That is what makes it quadratic, when the second differences are the same. And there you have it, it's quadratic. Okay, in this problem, we're going to determine which model best describes the data and then write an equation. So look at all these y's real quick. What do you think you're doing? Okay, well, I'm multiplying by 8, right? Negative 8 times 8 would give you negative 64. Times 8 gives you that. Times 8 gives you that. So we are multiplying by the same number. So that means that this is exponential. Okay. Now, to come up with the equation that best models it, the exponential equation is y equals b to the x. B is the number that you're multiplying everything. So B, in this case, is going to be 8. A is always your y-intercept. So wherever x is 0, your A is going to be what the y is. So actually, you can write it y equals negative 8 to the x. Notice the 8 is in parentheses because that is the only thing that's being multiplied. You can write the negative 1 there, or you can just leave the negative sign. Okay, so in this problem, I know it's one that you would do, but let's do it together. So let's try to see, are we multiplying the same thing? No. So I'm going to add 3 to get from 0 to 3, add 9 to get from 9 to 12, add 15 to get from 12 to 27, and what do I add to get from 27 to 28? 21. Okay, so clearly it's not linear because those are not the same. So then, that was lovely. Okay, so then I'm going to see, what do I need to multiply? No, what do I need to add to 3 to get 9? 6. 9 to 15, 6. 15 to 21, 6. So since all these are the same, the second differences are the same, it is quadratic.